All right, here we go. How much heat is required to raise the temperature of 150 grams of iron? Okay, so I have a temperature change, so I know the formula. MC delta T. I know my variables, Q, M, C, delta T. I know delta T means I need to have final temperature and initial temperature because delta T is final minus initial. Okay, so let's see. 150 grams from 20 to 25. So 20 is initial, 25 is final, and then I have the specific heat, 480 joules per kilogram degrees Celsius. Okay, so I have degrees Celsius. That's awesome. So let's find delta T really quickly. So 25 minus 20. So that you should know is 5 degrees Celsius. I do have one problem here. See how this is in kilograms and this is in grams? I can't have those be different. That means I have to change this to kilograms. So if you remember, changing from grams to kilograms means moving the decimal point 3 places. So it's here. So I go 1, 2, 3. So this is 0.150 kilograms. That is important. If you don't do that, you're going to get the wrong answer. So you have to be careful, okay? So Q equals, what is M? 0.150 kilograms. What is C? 480 joules per, remember when it's per, they're really on the bottom, kilogram degrees Celsius. And then my delta T is 5 degrees Celsius. Remember to use that subtraction you did, not one of these numbers. Now this is simple. Let's look at what I can cross out. Kilograms. You see why that was important? I can cross this out. Otherwise I would have both grams and kilograms and not able to cross it out. So you have to be careful there. Leaves me with joules, which is a unit for heat. So I just need to do the math. 0.150 times 480 times 5 equals Q equals 360 joules. Two significant figures, two, beautiful. Okay, I have two. Technically, this has one significant figure, so if we wanted to round it, most of the time, again, for heat, you can just give the answer, but if we were going to round this to one significant figure, it would be 400 joules. Okay. All right, let's go on. Let's find another one. Find the specific heat. Clear this, of 350 grams of an unknown. I have heat, temperature, no phase change. Okay, so that just means all I have is a temperature change. Okay, so there's a temperature change. Q equals MC delta T. Q, M, C, delta T. Delta T, remember, is final minus initial, and delta T, so is final minus initial. Okay, so I have heat, 34,700 joules. Temperature rises from 22 degrees Celsius to 173 degrees Celsius. 350 grams. Find the specific heat. So that's what I'm trying to find. So that means I can find delta T. I have both of these numbers. So that's 173 minus 22. So let's do that. 173 minus 22 is 151 degrees Celsius. All right, let's plug it in. 34,700 joules equals 350 grams times C times 151 degrees Celsius. Okay, so I have C on this side. I want it by itself, but it's being multiplied by these two things. So in order to get rid of them, meaning move them to the other side, I need to divide this side by both 350 grams and 151 degrees Celsius. So I got to do that on this side, 350 grams, 151 degrees Celsius. So over here can cross out unit, 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 number, 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 left with C. Here I can cancel out no units, but this is appropriate because that's what specific heat values look like. Joules per gram degrees Celsius or joules per gram Kelvin. Since it's in degrees Celsius, I can just leave it. So I take 34,700. I'm going to divide it by 350. And then I'm going to divide that by 151. Now, notice how I did equals in between. Do you see what my answer is? If I didn't want to do equals in between, I would have to do this. 34,700 divided by parentheses 350 times 151 end parentheses equals, notice same answer, okay? These two have to be multiplied, then I can do the division, okay? Or you could have just multiplied these first and then plugged in the numbers. Either way, you're going to get there. So I have 0.65657, whatever, joules per gram degree Celsius is C. Go back here, my smallest number of significant figures is 2, so I have 0.66 joules per gram degree Celsius is my specific heat.